Hi class, today we're going to talk about continuity. This is a very important concept of functions. So as you can see, definition 1 shows you how to define continuity. Definition 1 requires three things. First, f of a has to be defined. Then we do need to have the limit, and then we need the limit of f of x as x approaches a has to be equal to f of a. So let's take a look at the first example. At which numbers is f discontinuous? So let's take a look at x equals 1. For x equals 1, clearly you can see that the function is not defined, therefore it's not continuous at that point. So f of 1 is not defined. So clearly f is not continuous at x equals 1. Now let's take a look at the next one, which is x equals 3. So x equals 3, you can see that x equals 3, f is defined at 3, which is right here. F of 3 is negative something, I want to say negative 1. However, the problem is the limit does not exist. Why is that? Because as you can see, the limit approached from the left right here is a negative number, but the limit from the right is a positive number. Therefore, we do not have the limit. So at x equals 3, it's not continuous at x equals 3, the function. The function is not continuous because the limit d and e. Now let's take a look at number 5. So x equals 5. As you can see, f is defined at 5, which is this point right here. The limit does exist. Why is that? Because if you take a look from the left, we have this limit. From the right, we have this limit. However, the problem is f of a and the limit are not equal. So that's a problem with x equals 5. So we have the limit x approaches 5. The function f of x is not the same as f of 5. So we have those problems, those numbers show this continuity. Anyway, I always say that a function is continuous when you can sketch the graph without lifting up your pen or pencil. Now let's take a look at this example right here. So clearly you see right here for part A, x minus 2 is on the bottom. So you can see that there's a hole on the bottom at 2. So for part A, see right here, that's a problem. So at that point, x is not continuous, and clearly you can see that x equals 2 will create the problem. Over here, you see that we have the function, and the function goes all the way that way, all the way this way. However, we have this continuity. You can see it, right? So f of 0 is defined, but you can see that the limit, you can see the function goes all the way, the function goes all the way. So the limit does not exist at x equal to 0, even though f of 0 is 1 right here. Okay, moving on to part C. You can see we have this the problem with f of a and the limit, right? So this is the limit, but f of a is right here, so we have a problem. So it's discontinuous at this point. Right here, you see we have discontinuous at so many points. This is the function that for part D, the function is called the greatest integer function, or you might heard it as step function. Anyway, so you see that for part A and C, we call removable. Removable because if you remove those 2 points, then we are good. We have a continuity. For part C, I'm sorry, for part B, B is the infinite discontinuity. Now for part D, that's what we call jump discontinuities. So removable is A and C, infinite is B, and jump is D.